Hello, welcome back. Today I'm going to address a problem which is becoming more frequent, that is that these engines are getting higher mileage on them and needing a little bit of repair work, and what I'm talking about today is a complete top end rebuild. And the car I'm looking at, I replaced a cylinder head on a little while ago because it had dropped a valve seat, and now I'm looking at the cylinder underneath that, which we spotted at the time had been quite badly scored, and I've now got the job of putting a new rebored cylinder on there. So the original job involved cylinder head. Cylinder heads crack across here in between the two valve seats. And what happens then is the recesses for the valve seats open up when the engine gets hot, and normally it is this exhaust valve which drops. If you're lucky, it doesn't drop all the way out, and very often the valve itself holds the thing in place. Although it is dislodged, the valve then doesn't seal properly, and more importantly, the valve doesn't dissipate its heat, or shall I say the heat from that valve is not dissipated into the aluminium cylinder head because of the air gap behind the valve seat. So the answer to that is to get the head off, obviously, clean it all up, remove the existing valve seats, the old iron ones. These are sintered iron, I believe, and having got them out, grind away the aluminium all the way down to the bottom of the crack, and they do go quite deep. I've done about 15 of them, and they go a long way down. And then we weld that up, dress it all back to shape and get it nicely shaped up, and then recut the recesses for the valve seats, make new silicon bronze valve seats and cut them to fit the valves. Silicon bronze is good because it has much the same or a similar expansion rate to aluminium, so it's less likely to fall out when the head expands. And the other thing we do is we put some grooves in the back of that, little ridges in the back of the bronze seat, so that it bites into the aluminium when it contracts after it's been shrink fitted. That gives you a better chance of it staying put. So that's the job we did on here a little while ago. And while we were in there looking at it, we noticed that all down one side of the cylinder was badly scored and the piston was damaged. Not enough to stop us putting it back together, but the thing burns oil and needs to be sorted out, and that's what we're going to do today. The reason we waited was because I was waiting for these new pistons to arrive, and these new pistons are 0.5 millimetre or 20 thou oversize. I have opted to go for a slightly wider surface contact on the skirt and not to have the plastic overlay which are on the originals, because as far as I can see, whenever you take a piston out, that plastic overlay is worn away, sometimes even broken off, falling apart. I'll show you examples of that if I can later. And that overcomes, or I hope it's going to overcome, one of the problems, which is when you, as the Americans call it, lug the motor or labour the motor by using wide throttle openings at low RPM. You tend to tip the piston sideways slightly, and this makes it burn more oil, which is why they tell you not to do that. And I'm hoping that this slightly bigger surface area contact here will avoid some of that movement, may make the thing slightly less susceptible to damage in that respect. The other thing I've done is where we've had our friend down in Preston rebore this cylinder for us. The piston manufacturers tell us that the clearance on that piston should be 0.004 of an inch, and if it's a special purpose engine or if it has any abnormalities, then we're encouraged to put a slightly larger clearance on. They don't give you any figures, of course, so I've opted to go for 0.005 of an inch, because I believe we have a special case with this V-twin engine, and especially the installation in this Morgan car, because we have this cover on the top here, this plastic thing which supports the electric fan. Some people think that that's an air scoop. and if it is, any air pressure that is generated by air going in there comes round to the centre of the cylinders here, or between the cylinders, and opposes any natural air pressure going in this direction to cool those fins in the middle there. It also prevents any air from the cooling fan from getting through between the cylinders as well. So I think this engine has a tendency to overheat on the two faces which are towards each other in between the cylinders. And that seems to be the evidence from all the ones I've had to repair so far, is that it's that side that seizes up. So I think we've got, especially with the fan on here, but in most V twins, a little bit of an abnormality in the way the cylinders heat up. They get hotter in the area between the two, in the V, the inside of that V formation. So we've given that piston another thousandths of an inch of clearance. So if you'll bear with me while I get myself sorted out, we'll start to take the thing apart and see what we find inside. See you later. So the first thing we're going to do before we start dismantling anything is obviously remove the bonnet, and then I have disconnected the earth lead from the battery. That's very important, especially when you're taking the engine apart, because you don't want somebody accidentally pushing the starter button and breaking all your fingers or doing huge damage to the engine or whatever. Next thing we've got to take off is the fan. There are two screws in the top here. They're Imperial Allen key size. They're 3/16 Allen keys. Take those two bolts out, put them aside, and when we lift that cover up, you'll find under there, apart from the dead wasp, you'll find two aluminium spacers. Don't lose them, don't drop them down inside the engine there, or you'll have trouble finding them again. And then I'm just going to bring the camera over and show you down here. He said, getting that one wrong, is a connector. It's got a plus marked on it, but it's not difficult to get those the right way around when you put them back in. But the blue cable goes to the plus sign. Pull that out, and then that is the connector for the fan. You can remove the fan. Okay, so when we've got the fan off, we need to disconnect all this electrical stuff. The connectors here to the fuel injectors have a little spring clip which you push inwards. Don't make the mistake of pulling it out, because it will go flying off across the workshop. Let me take those two off. We've got one that swivels around under here, which comes out like that. Nice purple seal on it. This one has a nice blue seal on it. And you don't have to worry about which of these goes where when you take them off. Don't forget the knock sensor and the temperature gauge. Knock sensor is under there. When you come to put these back on again, they are all different. There is no way you can make a mistake and get the wrong one in the wrong place. Come around the other side of that. This little one in here has two clips retaining it, one top and bottom. You need a little screwdriver to get the bottom one off. And I've found this one has a tendency for that little brown seal to get stuck in the socket, which is not a problem, but just be aware of the fact that you don't want to lose it. And there's the bottom one under there. They all come off like that. We also need to pull off this hose. We've got a bolt which holds the knock sensor to the rear cylinder. And just be careful when you take it off. Behind it is this steel disc. So the bolt goes through the knock sensor first, then through the steel disc, and then into the cylinder head. Make sure you don't lose that steel disc. So I'm now disconnecting the petrol pipes, and I'll show you in a second how that clip works. But something I've just to be safe, I've made up a little piece of tube with two connectors on, which I can fit to the ends of the pipes coming up from the tank, because there is a possibility that if the tank is really full and you disconnect those, then over a short period of time you'll get a little seepage of petrol that will drip all over the floor, which is dangerous. So it's good to cap those off in some way or other. And the other thing I do, one end of my little pipe has got a bit of red around it. I use red for the port side or left side of the vehicle, so I know that that one is the one that goes to this left-hand hose. If you're in doubt about how to get these hoses off, it's a little right-angled connector down there, and here in the back you can see on the outside of the bend the little piece that you push in. You'll need the aid of a screwdriver, your fingernails probably won't be strong enough. Push that in, and once that's pushed all the way in, you can then just pull the connector apart. When you put it back on again, just push them in and they snap in place. Just make sure you hear that snap. Okay, now we've got to disconnect this throttle cable, and if you take a piece of soft copper electrical wire with a loop in the end, down the bottom there's a little button that you can hook it round and lift up, and that spins the disc in our direction so that the cable is now free. And with a little bit of jiggery pokery and the aid of a screwdriver, we can get that nipple to come out of the disc. Having done that, you can let this clip off and we're ready to move on. It's good to get all of these cables tied back out of the way. I just wire them up to the neck of the oil tank there. And then the next thing we've got to do is to undo the two screws here. I've already loosened them off, which hold the fuel injectors in place. Put those screws away safely. Something you'll notice with a lot of these screws when you take them out is they have this white aluminium oxide corrosion all over them. It's a good thing to put a little bit of grease or something on there to stop that happening when you put it back together. Wire brush all this old stuff off, and a little bit of grease before you put it back together. It will make it much more likely to survive the life of the engine and much easier for the next guy to get apart. And it got those out. We now lift the fuel injectors out of the holes where they sit. You'll see this one has come out with its cap. This one has stayed put, but is easily pulled out. They're only a tight fit on these O-rings. See, this one's quite mucky. I don't know why. We'll make sure it's all clean before it goes back together. I'm just going to pop. And the next job is to undo the 4 screws which hold the inlet manifold in place, and to take off the cover and the screws which hold the air filter. When you take these air cleaners off and you hold them up to the light, I don't know whether you can see any daylight through there, but you can see if they're clean or not. And here you can see a slightly discoloured area where the air comes in through the cover at the bottom there. It's not particularly dirty. I don't think there's a fly stuck in there, but I don't think that needs replacement yet. But if you're in any doubt, if that looks as though it's all blocked up and filthy, then just get a new one. If you look on the Morgan Three-Wheeler Club's alternative spares list, you'll find out where to go and buy a filter at slightly less cost. When you remove these 3 screws which hold the air filter backplate in place, you'll find they've been Loctited, and that's not for no reason. Should one of these 3 screws come out, there is only one place they can go, and that is into the engine. I've seen what it does to one of these cylinder heads. When one of these screws gets in there, it makes a very expensive mess. So make sure you Loctite these in place when you put them back in. Once you have the filter backplate off and these 2 Allen screws removed from the back, you can loosen the 2 hexagon head bolts down there. Just pull these 2 flanges towards each other. You might need to get a little lever in the back there and lever them gently. Don't do any damage to the aluminium castings. And then you should be able just to slide that with its slotted holes. You can see here these grooves are slotted. You can slide that off of those 2 hexagon bolts, so you don't need to take them right out. Next thing we need to do, you get a pair of pliers and just loosen off these clips and remove the breather pipe. Just to show you how these clips work, they're funny little things. As you can see, they've got some little tabs that point down, which you can get hold of with the pliers, squeeze them together, and then you can slide the clip up the pipe out of the way and just leave it on there. That leaves you free to pull the pipe off of the nipple sticking out of the crankcase. Now we've got to remove these exhaust pipes, and you'll find on the standard version that these nuts have a tab washer that goes around and connects both nuts together, and have a little tab that folds down. You can see where I'm putting that chisel now. That tab folds down and prevents the nut coming undone. I will show you a different system. I will show you a nicer system for putting these back together with brass nuts, which are to some degree sacrificial and don't risk damaging the threads on the studs or in the cylinder head. Okay, so our next task is to get these rocker boxes off. Get the screws out easily. The rocker box just lifts away quite easily. The gasket will probably work again, but I think we'll replace it anyway. We'll scrape that off later once the head's off. The next thing to do is to remove these rocker arms. So once the nuts are off here, you can just lift these rocker arms off. Don't lose the washers. And you'll see I've marked them FI for F inlet, or front inlet. This is the front cylinder. And I've marked the other one FX. That's the front exhaust. I'm not sure that's terribly important, but the manual does say you should mark them and put them back where you got them from, so that's what we're going to do. You can now lift off, although sometimes the studs are a bit tight and don't allow you to move it. You can lift off this bracing bar underneath, and that is marked F for front, and it only goes one way round. You can't put it on the other way round, it doesn't fit, so you've got no problem with that. The next thing we're going to pull out are the push rods. Just lift them out, and again, just you're going to use a piece of masking tape and mark them in exactly the same fashion. FX for exhaust, and the inlet one accordingly. So having got the push rods marked and put away, we're going to go around and just slacken off these head bolts. I like to just ease them all a little bit before I slacken them right off. They're a 1/2 inch AF spanner, and you need a 12-point spanner to go on them. They're not hexagons, they're 12-pointed heads. So when you've got them all loose, I have a magnet on a stick here which helps to get them out. And don't forget to pull these washers out as well, because they're big, heavy washers, will not be easy for you to replace if you lose them. And don't drop them down the pushrod tube holes. Now, having got all the bolts and washers out and safely away, you'll find you can lift the cylinder head off, and in this case the pushrod tubes have come with it. They are only held in with O-rings. You can see they just press in, same at the bottom. So take those out and keep them separately. I don't think you need to mark them. And put the cylinder head somewhere safe where it won't get damaged. And there we can quite clearly see all the scoring down the side of the barrel, and as I said earlier, this is on the side adjacent to the other cylinder, so the area where it gets hottest. Now that we have the cylinder head off, you should find it fairly easy just to lift the barrel away, being careful not to have that piston flap about too much. Put the barrel down safely, and then I'm just going to turn the engine over a little bit to bring that piston up higher and fill the top of the crankcase with rags to stop anything accidentally falling in that hole. Now, with the use of a pick or a tiny screwdriver, you can get in through that little notch there, and you can lever behind the circlip, and there's the circlip. Please wear your safety glasses when you're doing this, because those circlips can, if they get free, fly off at quite some speed. We can then push that gudgeon pin through from the back and lift the piston off. And there we can quite clearly also see serious scuffing down the side of that piston where it's seized at some point. And if we turn it over, interestingly, we can see the outline where the plastic coating was applied, but the plastic coating, with the exception of that little bit there, has completely disappeared. So I really don't understand the point of putting it on there in the first place, but I guess there must be one. This is, by the way, not surprisingly, it's not a standard forged piston, or that, well, maybe it is forged, but it doesn't look like one of the originals that I've taken out of other cars. This one looks rather more as though it's machined from solid. Well, maybe this area shows that it's otherwise. So now, with the piston removed and everything nicely packed with tissue to stop any foreign bodies from dropping in or any dirt, we can clean around that bottom gasket face, removing the gasket obviously first. Make sure that that's all nice and clean, ready for the new one to go on, and then we can start looking at getting the cylinder and the piston ready to refit. Or not refit, getting the new cylinder and new piston ready to be fitted. Looking through the cylinder now that it's been removed from the vehicle, we can quite clearly see that vertical scoring that runs all the way down to the bottom. The cylinder base gasket has been removed, and the face that it sits on the crankcase carefully cleaned without scratching it. And the best way to do that is to use an old wood chisel, which is all very smooth and nice, just with the razor sharp edge rounded slightly so it doesn't dig into the aluminium, and the corners rounded off it as well. And then once that's done, just polish the surface over with some Scotch-Brite, making sure all the time not to get any of that dirt falling down inside the crankcase. Maybe a little overcautious, but better safe than sorry. I have slid plastic tube over all the studs so that we don't actually run a risk of damaging the piston while we're fitting the gudgeon pin and getting it ready to go into the cylinder. The rings as supplied need to be gapped, and you can see this is a ring straight out of the box, and just there you can see that the ends of the ring are actually touching together, and what we have to do is file a little bit off the end in order to get a gap. To file the end of the ring and produce the gap that we need, you first of all need to hold the ring really near the end, because you don't want to be bending it and snapping it off, and you need to be holding it in soft jaws. These ones are brass, so they don't damage the face and top and bottom of the ring. And then when you put the file on, just feel where that flat spot is and carefully file away some material from the end, trying to keep it absolutely square in both planes. And now with the ring filed down and all nicely deburred and cleaned up, we can just check with a feeler gauge and just see that that's the right gap in there before we fit the ring onto the piston. And each set of rings comes with a little leaflet which tells you exactly what the gap should be. Just out of interest, the gap on the top ring, this is the bottom one actually, is slightly tighter than the bottom one to allow gases to escape back down into the piston and not build up between the two rings. You can fiddle these rings on by hand, and certainly the oil ring and its two solid rings can be fitted by hand, but when it comes to doing these compression rings, far better to use an expanding tool. It's a rather odd thing that moves in funny ways, but makes it much easier to get these on without doing any damage to the piston. Pay attention to which way up they go. The little leaflet tells you what's what, and then when you've got them on, space the gaps so that the ends of the rings, space them about 120 degrees apart, and the oil ring as well, get the oil ring ones around there. And then when we put it back together, there will be no direct pass between the gaps, although I suspect they do shift round as the engine's running, but we'll give it the best start we can. These wire circlips are quite difficult to install in standard pistons, but these ones have quite an extra bit of depth where the gudgeon pin goes through, and so I don't know if you can see down inside there, the circlip groove is quite a long way in, so it makes life fairly difficult. And I've made a special tool which is just a piece of steel bar, which is a nice sliding fit inside the gudgeon pin. It has a roll pin which is inserted just shy of the diameter of the gudgeon pin, so that when you put it together and you insert that inside the gudgeon pin, that roll pin moves around freely without touching the inside edge of the piston there. Now, when we start, the first one we put in is going to be in the back of the piston, and it's important to identify the fact that these two valve cutouts go towards the front, so the back one is this side. That's the one we're going to put in first. And the way we do it, something else that's important to note is that there is a little groove down there into which you can insert a pick in order to get these things out. Whatever you do, do not line that clip up so that the hole or the gap in the clip is lined up with that slot, because then there's nothing for you to get a pick behind and you won't get it out again. So you need to make sure that that is round there some distance away. Get one end into the hole, and you might have a bit of a crazy angle. Just turn that round, I need to push it back out towards me just to get the clip into its hole like that. So that's the easy one, which we can do here. Now the rather more difficult one is going to be putting the one in the other end after we've got the gudgeon pin fitted through the end of the conrod in the small end bush. But we'll come back to that in just a second. Something that it's important to remember to do is to lube everything up with something thick and sticky. And this is assembly lube, they call it. Just a liberal smear of that on all the appropriate moving parts. Putting a bit on the gudgeon pin there. And with any luck, we should be able to get that pin to slide right through to the back. You'll see I've got these plastic sleeves over the studs here to prevent any damage to the piston while we're doing all this pushing and pulling, getting circlips and things into place. I'm going to put the front circlip in using a special tool in the same way as you saw me do one at the back. And I'm afraid my hands are probably going to get in the way, so you won't see this terribly clearly. You'll notice I've got plenty of paper packed in around there in case I drop this circlip. I don't want it going down into the crankcase. So, putting my specially made tool in there, making sure the gap in the circlip doesn't line up with the removal slot. Pop. Just looking to make sure that's fully seated, and it isn't. Now it is. So there we go, that's ready now to have the cylinder slid over the top. You can see here the old cylinder that I've taken off and the reboard one that I'm going to put back on, the one I've just cleaned. And you'll notice that the old one has shiny metal edges to the fins. Now the way that's achieved is by spraying on the crackle finish heat resistant black paint and then machining the edges off afterwards. Well, A, that's a very long and tiresome process just for the sake of a bit of finishing, and B, I think it causes problems because you often see that right on the edge there where the paint is exposed, the corrosion starts to get in the aluminium underneath the paint and the paint all starts to flake off. This one hasn't suffered it, but many of the older ones do. And what I've done is used a heat resistant black spray paint, and I've painted right over the edges, which is a little bit quicker and a little bit easier, but I think it also gives a better job because you don't have those exposed edges of paint. The paint wraps right the way around the edge of the fins. Now, as you probably know, we need to use a piston ring clamp to clamp these rings into the piston in order to enable us to slide the cylinder over the top. And the ones you buy for motor cars are quite readily available, but they don't come apart easily for you to get it off after the cylinder's in place. Because motor car ones work the other way round. You push the conrod and the piston down into the block, leaving the clamp free at the top. Whereas a motorcycle engine, you've got the clamp left hanging around the conrod and you need to get it off. So I use these large hose clips, stainless steel. They've got a bolt which can be completely taken out of there to undo it and get it off afterwards. They're just deep enough to cover the rings. They come with a stainless steel shoe which comes round inside here to stop the hose from sort of bulging out underneath where the screw is in that gap. Well, we don't have that problem with piston rings, and I don't think we want the edges of that shoe digging into the piston either, so they're quite easy to remove. You just pry them off. They're only bent over the edge to just hold them in place. Pry them off with a screwdriver, and it leaves you with a perfect clamp for putting on these piston rings. Now, as I said earlier, we need to make sure that the rings are in position so that the gaps are at about 120-degree intervals around the outside. And then we just carefully slip our ring clamp over the top, tightening it up carefully so as not to accidentally clamp onto a ring which isn't properly in its groove. And I can see that they're all going in very nicely and very freely. And when we get to the point where they are fully closed in position like that, we can just back it off a couple of turns just to make sure that that clamp is able to slide down when we push the cylinder into place, and then we're ready to do exactly that. But what I'm going to do before I do that, now that you've seen how it works, I'm going to take the clamp off again and put some of that assembly lube on the rings, and I'm going to put a good generous smear of assembly lube in the bore. What we want to avoid here is any chance of a dry startup doing damage before we've even got the thing going. So I'll be back in just a second when that's all done. Okay, so here we are with everything greased up nicely, or coated with assembly lube, as they call it. I've got the ring compressor in place. I've got the piston slightly below its top dead center, because I want to be able to drop the cylinder into position. And as you saw then, I've just got all the cylinder bolts entered in the holes, because otherwise trying to get the rings into the bottom of the cylinder at the same time as you're trying to line those holes up is very difficult. The other thing I would recommend, and just be careful here that you don't have the engine revolve and trap your fingers, is because these pistons are so short, they do tend to tip sideways slightly. So you'll see I've got my fingers under both sides of the piston, and I'm effectively pulling the piston up into the cylinder while I use my chest on top of the cylinder to slide the whole thing down. That way I keep the piston reasonably level and I don't have a ring popping out just to one side. I probably forgot to mention that I've already got the cylinder base gasket fitted neatly down onto the top of the crankcase. It'd be very silly to forget to do that. The ring compressor has been pushed past the bottom of the piston, and now carefully, because we don't want to have any odd bits and pieces falling into that crankcase while it's open, I'm removing the bolt from the clamp, and you have to be wary of these little nuts in the end which could fall out. One has to be wary of these little barrel bolts in the end, which could fall out and get into the crankcase, and I carefully lift those out. Using a magnet, and then I can wiggle this clamp free, and that leaves me now able to just slide the cylinder down all the way over the piston, down over the locating dowels, and nice and flat on top of the cylinder base gasket. And I've got a good residue of that assembly lube up there, which I'm just spreading around, just to make sure that the first time those rings move in the cylinder, they are well lubricated. Here you'll see I've cleaned off the gasket face of the cylinder head. The whole cylinder head has had the soapy water wash treatment, and now I'm just going to use a dentist pick or anything similar to that will do the trick, just to get in there and hook out the O-rings which seal the top of the pushrod tubes, and then we're just going to give that a little clean up and pop a pair of new ones in and do the same at the bottom, and that'll be ready for the head to go back on. So I've now used a dentist's pick again to remove the two O-rings up here, and I've put two new ones in. The O-rings, both top and bottom, have got a light coat of that assembly lube on them to make it easier to get the pushrod tubes to pop into them. And it's good at this point, if you're not familiar with it, to have a little look down inside there and just see what that looks like. Because later on, when we put the pushrods back in, you've got to make sure that that pushrod drops nicely into the cup that you can see on the left-hand side there, and the cup that you can see in the middle in that shot. So make yourself familiar with what that looks like, because you'll need to be looking at it closer later. Okay, so here's the cylinder head. It's had a nice clean up. I clean off this gasket face completely because it gets a deposit of carbon around there, and you don't want any of that carbon deposit overlapping the gasket. This one wasn't terribly badly coked up on the inside because this is a head that I repaired and fitted not very long ago. We've got the new O-rings in the top here, and I find it is better to fit the pushrod tubes into the bottom O-rings first, because if you put them into the head first, you find they don't fully insert at the bottom. Now the head gasket is all in position on there, nice and clean. I'm going to put the head on top. It's a bit tricky because you've got to line all the studs up at the same time as getting these O-rings to go in. There we go. Also got, having got the O-rings in, there are two little dowels in the cylinder head which have to be engaged in holes in the barrel, and you'll see that these two bottom ends of the tube, rather like the undisturbed ones over here, they're right down tight into the O-rings. So now we can put the bolts in there and start to tighten up the head bolts. There's a lot spoken about the use of torque wrenches. I don't particularly like using torque wrenches without a little bit of thought about what we're doing. S&S recommend that these bolts be oiled before you, or the thread be oiled before you put the thing together in order to get the right torque wrench readings. But it's a lot more complicated than that. A torque wrench will give you a false reading, or shall I say a varied reading, depending on the surface finish of all the mating parts. That includes both sides of this washer, under the head and where it bites into the cylinder head, and also the mating parts of the thread. It's very difficult to sort out the surface finish on an internal thread, and so torque wrenches tend to be a bit unreliable. Just oiling inside the thread gives you an easier turn, therefore giving the torque wrench an easier life, and therefore getting the bolt tighter for a given torque wrench setting. But of course under here, under this washer, you've got a friction surface which is larger in diameter and therefore gives greater resistance than that which is given by the thread. So should we oil these or not? Who knows? The one thing S&S do recommend, which overcomes this problem, is they recommend that you first...
Oh, yeah.
All right, thank you very much. You're on camera.
I hope not.
They recommend that you first tighten this bolt to 8 foot-pounds, which is a very light torque, going round all the bolts. Then they recommend you go round again at 18 foot-pounds, which is still not enough to secure the thing. But what those readings are doing are settling the head down without compressing one side of the gasket more than the other. So getting it tilted, in other words. And then they ignore totally the torque wrench setting, which I think is a good attitude, and they tell you to finish off by turning that bolt a further 90 degrees. Now, moving it through a particular angle is far more accurate than relying on what happens, how far it turns with a torque wrench setting, all depending on how well it's lubricated, what the surface finishes are. And so I think that is probably a very good thing. The other thing I've noticed is, and there's a lot of controversy about this in the motorcycling and engine building world in general, I think that you should run these head gaskets in a little bit and then retighten them. And that's what I'm going to do on this engine. It's what I always do. The gaskets we're talking about here are a composite fibre gasket with a steel reinforcing ring around the inside, and I think that composite fibre settles down. At the very least, you should tighten these down, leave them overnight, and then tighten them down a little bit more. And by a little bit, what I mean is you're going to have to get a feel, possibly using a torque wrench, of how tight that 90-degree turn makes the bolt, and make sure that tomorrow morning, after the gasket has had time to settle in and compress, that it still feels the same. Again, use the torque wrench to get that feel right, if you will. I prefer to get the engine warmed up, let it cool down again, and then re-torque them. Take it out for a short drive. S&S's braking instructions are quite specific, I think somewhat over-complex, but they talk about starting the engine for 30 seconds and then leaving it to cool, and doing that 4 or 5 times. That may be the way forward. Do that if you wish. But certainly, after these things have first been torqued down, they need to have time to bed in, either leave them overnight or, better still, give them a short run. No big wide throttle openings, just a steady short run, and torque them down again when you've got it cooled down after that run. Right, I'm going to put these on now and show you the correct sequence in which to tighten them. Okay, so let's talk about the tightening sequence for these gaskets. This is the front cylinder, so this is the outside of the car, furthest one away from the centre of the engine, if you like. This one is at the front, and they recommend you start here. The way to remember the sequence is that you go round skipping one every time. So you go to this one, skip that one, do 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 this one. So you're going 1, 3, 5, 2, 4. That's exactly the same on the other cylinder, but S&S recommend you start on this one and go clockwise. So 1, skip 1, 2, skip 1, 3, skip 1, 4, skip 1, 5. Simple as that. The torque wrench settings should be first time round 8 pounds force feet, second time round 18 pounds force feet, and then third time round a quarter of a turn, 90 degrees further. You can get special wrenches that are marked 90 degrees, but it should be fairly easy for you to estimate that. It's quite an easy angle to remember. Let's go and do it on the car. Here we are with the bolts all in position. They've all been oiled. I've got my torque wrench set to 8 pounds force feet. And that's a very light click. So skip that one, move on to this one. Click. Skip the next one, come to this one. Click. Skip that one, come to this one. Click. Skip one, come to the one at the back, the last one, number 5. Click. We've now moved the torque wrench up to 18 pounds force feet. Click. Skip one. Click. Skip one. Oh, take the socket with it, hey. Click. Skip one. Click. Skip one. This is number 5 again, the last one. They are now all at 18 pounds force feet. Just got that wrench aiming forward along the length of the vehicle, and I'm coming around 90 degrees so it's across the vehicle. Skip one, come over to here. Again, carefully get that forward, running along the centre line of the vehicle, and move it across to 90 degrees. Quite easy to judge. Skip one, move over here, same thing. Skip one, move over here. Same thing again, along the centre line of the vehicle, round to 90 degrees. And then skip one and do the last bolt. And that's it. But I'm going to run this engine and warm it up, and then I'm going to take the rocker box off, and I'm going to check and see exactly how tight they are, and maybe torque them up a little bit more. But the easy way of finding out what you've got is to start with your torque wrench. winding it down and down and down. Until you just find that point where it clicks. If I make it tighter, it wants to move the bolt. So that's where I was, and if I read it off, we are looking there at 32 pound-force feet. So when we've warmed it up, we're going to check them again and make sure that they go at 32 pounds-force feet when we put it back together. Okay, so now we've got the head torqued down. We can now look at putting back the valve gear or the push rods. This thing is marked F for front, that's this cylinder on the left hand side of your Morgan. And it can only go one way because this end is longer, it won't allow you to put it on the wrong way around. Just drop that down and make sure it sits down nicely. The next thing we're going to do is to put back our push rods. And I've got this one marked front exhaust. Making sure that that is nice and clean. Now you'll recall we looked down inside at the top of the hydraulic tappets to see what it looked like. So we can now put that push rod down all the way and make sure that it sits nicely in the socket in the top of that hydraulic tappet. This is the inlet one, nice and clean again, carefully making sure that sits in the socket in the top of that tappet, because if it doesn't you could cause some serious engine damage. I'm going to put the rocker arms back on now. They had a little square locator underneath which fits in the slot of that crossbar under there. Just making sure that that sits nicely in position. And this one the same. Just make sure it sits with the push rod in the socket at the end. And now we can put the nuts on and tighten those up. Okay, so we've tightened down the two rocker arm nuts now to a torque of 30 pounds-force feet, which is what S&S recommend. We've got a nice new gasket to go on there. We've cleaned up the inside of the rocker box cover. Now I'm just going to put a couple of bolts in to get that gasket nicely lined up. And then pop it on, just enter those two. Now, if you look at the S&S manual, it tells you that these should be tightened to 120 pounds-force feet. I think they've got themselves a bit mixed up there. I think it should be 120 inches force feet, or only 10 pounds-force feet, because if you pull these down to 120 in an aluminium thread, you'll strip it. The other thing to be wary of in the manual, it tells you that you need to set up the lift of the rocker arms or the valves using a clock gauge. It's quite a complicated process, but I've spoken to S&S recently and they say that that part of the manual has been superseded and it's no longer necessary. So do what I've done in there, just bolt them down and everything will be fine. Okay, so there we are. We've rebuilt this front cylinder and the head, put it all back together. You've watched me do that. I'm now going to do the other side, the rear cylinder, and then when I've done that, I'll make another little clip for you to watch while I reconnect the inlet duct and the exhaust pipes and all the electrics, and then we'll be ready for a test drive. See you later. So here we can see the results of a dye penetrant crack test on the right hand cylinder head, or the rear cylinder head, and as you can see in between the valve seats here there is no sign of a distinct red line running across from valve seat to valve seat, which would indicate a crack. So this one can go back on. Okay, so now we've got both cylinders and heads back in position. I'm just going to show you a little tip to hold these washers back against the head of the bolt. Just something sticky on there. A little bit of grease would probably do it. If we hold those back against the heads of the bolts, it makes it much easier to get the inlet manifold back into place. So we need to just make sure that we've got these rubber seals still nicely in position. Push those flanges back a little bit, and then we should be able, those washers stuck back against the heads of the bolts. There, just snug those down into position. So here's the inlet manifold, or inlet tract duct, call it what you will, back in place, all bolted up. It's a very convenient time now, while we've got the air filter housing off, to put that throttle cable back in. So here's the air cleaner back in position, or the air cleaner back plate. Don't forget when you put that on to make a good job of Loctiting these three screws in place and tighten them up well, because if one of those comes out and goes, and it can go very little other direction, if it goes down there, you'll find yourself looking for a new engine. I'm not a great believer in using lots of Loctite, but the consequences of a screw coming loose are the thing that I look at most, and the consequences of one of these coming loose are very, very expensive. Okay, so now we're going to put back the two fuel injectors. Something I should have mentioned earlier, but it's worth mentioning now, is that under these towers that hold the injectors in place is a thermal insulator. Usually remains stuck either to the cylinder head or to the little tower. This one is stuck on the tower, the other one stuck to the head, but make sure you ensure that they are in position before you put it back together. Make sure everything's clean. A little bit of oil on those O-rings makes them go in a little bit easier. Drop the petrol pipes down the back. Don't forget that one goes underneath the accelerator cable. Just pop them back in so the O-rings seat down into the head, and then put in the securing bolts. Okay, so all that remains to do now is to start the engine, make sure it all runs nice and quietly, and then I'm going to talk to you a little bit about running in procedure for a top end rebuild. Let's see what it sounds like. there we are, everything seems to be running quietly. A little bit of rustling noise from the valve gear, but that's to be expected. The cylinders are certainly much quieter now than they were before we started. Now I'm going to take this car out for a test drive, probably 15-20 miles, make sure it's brought up to running temperature, and then when I bring it back I'll allow it completely to cool down, and then I will remove the 2 rocker boxes and check and make sure that the cylinder head bolts are sufficiently tight. And that's a little bit difficult because the tightening procedure, as you saw from the video earlier, requires you to turn the bolts 90 degrees because that eliminates the possible errors in a torque wrench. But I did check, as you saw, that 90 degrees brings us up to about 30 pounds force feet. And so what I'm going to do is just check and see if we are at 30 pounds force feet, and if we're not, then I will retorque them to that figure, which is about the best estimate we can make. Running in tends to generate very fine debris which gets circulated around the engine by the oil and hopefully pulled out by the oil filter. And the very worst part of the engine for creating that sort of debris is where the rings slide up and down inside the cylinder bore. We do, after all, finish that cylinder bore with a sort of cross-hatched pattern so that there is something there for the rings to bed into, and that cross-hatched pattern helps with the bedding in. Well, of course, that bedding in process involves a very small amount of wear, and that generates very fine iron dust. So the thing to do is to run it probably for 1,000 miles using low RPM, stay around about 3,000 at first, and then no more than 4,000 until that first 1,000 miles is achieved. Avoid what the Americans call lugging the motor, so avoid labouring it, avoid wide throttle openings in low gears, and then at the end of that 1,000 miles running in period, do an oil change, put a clean oil filter on, and you should have no further problems. So, if you're doing the job, I wish you luck with it. This one, I'm sure, is going to bring its owner many miles of happy motoring. Thank you very much for watching. Bye. Okay, so I thought it would be useful, if you're intending to do this job yourself, to have an idea of the stuff you're going to have on hand before you start. Obviously, if you're looking at doing a rebore, then you're going to want an oversized cylinder, and I keep these here in stock, bored plus 20 or plus half a millimetre. You're going to need an oversized piston to match. Again, this is plus 20. The pistons come with a ring set, gudgeon pin, circlips, so you get the whole kit there ready to use. You will also need some sort of ring clamp. I recommend these stainless steel hose clips, they fit nicely on there. You may find when you take it apart that you need a cylinder head that's been repaired if you've got this crack in between the valves. And I keep these here as service exchange cylinder heads, all repaired with silicon bronze inserts, and the valves all ground to fit, ready, rebuilt with springs and everything on. And then when you come to putting it all back together, you're going to need a cylinder base gasket. That's the one that goes under here. You are going to need a cylinder head gasket. He sits on top there. You are going to need a rocker box gasket, and obviously one of each of those, depending on whether you're doing 2 cylinders, you'll need two of each. You will quite possibly need a gasket for the back of the throttle body. You will need O-rings for the top and bottom, or the other way around actually, for the bottom and the top of the pushrod tube, and 2 of those for each cylinder that you do. So if you're doing both cylinders, you'll need 4 of each sizes. And on top of that, the shelf, I keep repaired cylinder heads on the shelf, Again, service exchange, you come complete with the valves and the springs all fitted. I keep all the gasket sets, complete engine sets if you want them. I keep the pistons, ring sets, gudgeon pins and everything. So if you're going to take this job on, please do feel free to get in touch to get all the bits. Good luck with this project. See you again soon. Bye bye.